Hello everyone, I am Akhilesh Kumar Srivastav from ABS Engineering College, Ghaziabad. In the last lecture, we have discussed about the cooperating and the competing processes. We have seen that where the conflict arises in between the cooperating and the competing processes, wherever the shared memory is used, that is the critical section, and we should find out the solution to the critical section. So, in today's lecture, we will be discussing about some of the solutions to the critical section, and later we will extend this for finding out a consistent solution which can be applied everywhere. So, the outline of today's lecture will be that we will first be discussing about the cooperating and the competing processes, then we will see the need of the synchronization. This will be just a quick recap of what we studied in the next turn on the last turn, and then we will see the solution, which is using the lock variable. We will then see the extension of the lock variable with the help of the test set lock, and finally we will see the priority inversion. Now, let us have a quick recap of what we have actually discussed on the last turn. We have discussed about the cooperating and the competing processes. A cooperating process is a process which generates something and the other process consumes that thing. It means that those processes are cooperating. The competing processes will be those which try to use the common resource, and there is a competition between these two processes for the usage of that common resource. Whosoever wins is the winner. It means that process will be using the resource. Now, we have taken an example of this two processes in which we have the P1 and the P2 process. In the code of the P1 process, we are somewhere using the updation on the common variable count, and in the code of the P2, at some place we are using the decrement in the count. So, increment in the count and the decrement in the count, these are access to or modification in the common variable. We cannot allow these two operations to go in parallel. Okay. So, if P1 process runs, then P2 process runs. If the initial value of count is 5, so P1 process will make it 6, then P2 process will make it 5. So, final value what is expected is 5 from these two processes. Now, we have discussed about what problem may arise actually in case the value of count is incremented and decremented by different processes. In the computer, while doing the compilation process, the compiler will divide your statements into the statements which can run in unit time or in one CPU cycle. So, these are the assembly language instructions for the given count plus plus, and this is the assembly language instruction for count minus minus. So, let us say this is the P1 process and this is the P2 process. The P1 process increments the value. So, this is done in 3 steps. The first step says that transfer the value of count to R0 register, and then increment the R0 register, and finally move the value of the R0 register in the count. Similarly, in the P1 process, what is done? First move the value of count in some R1 register, and then decrement this value, and finally transfer the R1 register's value in the count. So, in case we allow these statements 1, 2, 3 here for the P1 process to run, and then 1, 2, 3 statement of P2 process to run, there is no problem. The value of 5 will go up to 6, and then the value of 6 will go down to 5 for the P2 process. So, 5 is the final answer. Now, if we allow the preemptions to take place in between, if we can say that after execution of some statement the process is preempted, other process is given the chance, and after some time that process is preempted and first process is given the chance. So, in that case, let us see what will happen. The P1 process runs the statement 1 and 2. We are taking the example 5 only, or the initial value of count is 5. So, the value of count is 5, which is transferred to the R0 register. So, R0 contains 5. Statement number 2 says that increment the register value. So, register value is incremented to 6. Now, after this it is preempted and P2 process executes statement number 1, 2 and 3. So, for P2 process the value of count has not been updated by the P1 process yet. So, the value of count obtained by the R1 register will be 5 through the statement number 1. the statement number 2 finds out its value as 4 because a decrement operation is being performed at R1 register, and then the value of R1 register is shifted back to count. So, the count contains 4 now, after which this process completes and the P1 process executes from a statement number 3 which says that transfer the value of R0 in the count. So, the value of R0 is 6 and it will be transferred to count. So, count contains 6 now. So, as a result here count contains 6. Now, there is another scenario. In this, count value is read by the P1 process, it means in the R0 register, then incremented. So, R0 register contains 6 here, and then with this the R1 register contains 4 here, because through the statement number 1 process number 2 in this R1 register will read the value of count which is actually 5 only. After this is decremented. So, decremented value of R1 register is 4. After this P1 executes the statement number 3. Statement number 3 says that transfer the value of R0 into the count. So, count contains 6 here, and then P2 executes the statement number 3 by which count will contain 4. So, the final value of the count is 4, which is not consistent. Okay. We wanted the value to be 5. So, if we are allowing the preemptions to take place, it means that the statements execution, then preemption, then a statement execution for the two processes is actually making the value of count as inconsistent. So, we should follow some rules, or we should apply some conditions by which this inconsistency does not take place. Okay. So, here what is happening, that if P1 process is finishing first, the value of count is different. If P2 process is finishing next, the count value is different. So, there is a race between the two processes to update the value of the count. Okay. Now, we have also seen that when we are writing the code, in the place where the value is updated or the common value is updated is known as the critical section. So, this is the program in which there are several lines written, out of which there are some places where the common variables are used. So, those places are known as the critical section. We may use the count variable, or we may use the shared value or shared variable multiple times in the same program. Okay. So, before the critical section the part is non-critical section, after the critical section the part is non-critical section. So, no matter what is written elsewhere, but we are more concerned about the critical section. When we are finding out the solution of the critical section problem, then we should ensure that the entry to the critical section is allowed to one process only. If we try to allow only one process to enter, we should apply some conditions before entering to the critical section. It means a process has to enter the critical section, then there should be some conditions that it should check. If those conditions are satisfied, then only the process is allowed to enter the critical section. If not satisfied, it will either wait or it will keep waiting. So, a critical section has to be accessed, before that an entry condition is applied. So, we are saying that that is the entry section of the program, and then when the critical section is exited, it means a process exits the critical section execution is over, then we will say that we are in the exit section. So, first we were in the entry section, then the critical section, and then the exit section. So, this will be the execution sequence. So, all those conditions that we have applied in the entry section, that will be removed in the exit section. So, all the synchronization problems should actually do this. We can use many techniques for doing so, but whichever techniques we are applying, we should ensure that those techniques should allow the mutual exclusion, the progress property should be satisfied. Meaning of the progress property is that if one process does not want to enter the critical section, it will not restrict other processes to enter the critical section. Okay. If a process has to enter the critical section, then only it should check the entry condition. If it does not have to enter the critical section, it will not check that. Okay. And then the bounded wait condition, it means a process which is trying to enter the critical section cannot be allowed indefinitely. If it is allowed indefinitely to access the critical section, that means the other processes will starve, there will be starvation for the other processes. So, we should apply the mechanisms such that the bounded wait condition is satisfied. It means that a process does not enter in the critical section indefinitely. There should be some check applied or some time allotted after which the process should not be allowed to enter the critical section, and the others who are waiting to enter the critical section, they should be allowed. And finally, the architectural neutrality, it means the solution that we are designing should not be designed only for certain machines or certain softwares. For example, if I have designed the synchronization mechanism and that runs only on the Linux platform, it does not run on the Windows platform and it does not run on the NT. So, that solution is worthless. Similarly, if you have designed a solution that runs only on the Pentium machines and it does not run on the Celeron and the earlier versions or the processors of the other companies, so that solution is wasted or that solution is wasteful. So, our solution should follow the properties of mutual exclusion, only one process can enter the critical section at a time. It should follow the property of progress, it should follow the property of the bounded wait, and it should be architecturally neutral. So, now let us deal with the first solution in hand, that is the use of the lock variable. Okay? We shall first deal with the use of the lock variable and then we will see that what is the problem with the lock variable. So, first let us check that whenever a process has to enter the critical section, it has to use a lock variable. Okay? So, there is a lock variable, this is the solution. Statement number 3 here is the critical section, CS means the critical section. Okay? And then statement number 1 and 2 are the entry section statements and statement number 4 is the exit section statement. So, what is the entry section statement saying? First understand that what is the value of lock. So, meaning of lock equals to 0 and lock equals to 1. So, there is only two values the lock can take. Lock equals to 0 means critical section is not occupied. Lock equals to 1 means critical section is occupied. Okay? Here lock, meaning of the lock as 1 means the critical section is occupied, and lock equals to 0 means nobody is using the critical section, it is free. Fine. Now, this solution that we are designing is a busy waiting solution. Understanding the busy waiting solution, what is the meaning of the busy waiting solution? Let us say there is a dressing room, and in the dressing room a person has to go in. Let us say somebody is already there in the dressing room. So, that person keeps knocking at the door, it is continuously knocking at the door until the person in is coming out. So, this is the busy waiting solution. What could be the other method? If a person has to enter the critical section, it means it has to enter the dressing room, he knocks once, the dressing room is busy, he goes and sits somewhere else. Okay? And then once the person inside the dressing room exits, he enters the critical section. So, this is not a busy waiting, the person is not knocking at the door continuously. Person has checked it once, it is busy, goes and does some other work. Whenever the critical section will be free or whenever the dressing room will be free, he will be called for entering in the critical section. So, let us see this solution. When the value of lock is 0, this is the busy waiting solution. When the lock value is not 0, we will keep checking this condition. Semicolon means we will keep checking this condition, busy waiting, the CPU is always busy. Okay? If the value of lock is 0, it means the entry to the critical section can now be allowed. So, while entering the critical section, the entry section sets the lock as 1 such that the other processes check that the value of lock is 1, it means someone else is already there in the critical section. Fine. And then the critical section is accessed, and after exiting the critical section, the value of lock is set to 0 such that other processes can check it that the critical section is free now. Okay? So, while entering the critical section, we have checked if the value of lock is 0. If it is not 0, we keep checking. If it is value is 0, it means the critical section entry can be done. So, before entering, the lock value is set to 1, and after which we enter the critical section, and when the execution of the critical section is over, we will set the value of lock as 0. Fine. So, we have taken the example of the dressing room. So, the dressing room, In the example of the dressing room, what we have said that the dressing room, there is a tag here, okay. The tag is either vacant or occupied. So vacant means the lock is 0. If it is occupied, O means the dressing room is not free. Now whatever we have written means this condition, while lock is not equal to 0, keep waiting. We need to expand it in the assembly language code. So let us expand it in the assembly language code. The value of lock is stored in R0 and then it is compared with R0. If this value is 0, it means the entry to the critical section is allowed, and if the entry to the critical section is not allowed, then go to the step number 1 and again check this. So this is in the loop, jump if not 0, Z and Z means jump if not 0, go to the step 1 and do it again, and when it is 0, we come to the step number 4 and set value 1 in the lock, lock equals to 1, after which the critical section entry is there, and then when critical section entry is completed, you can store a value 0 in the lock such that the other process can enter the critical section. Now let us see it with the example. This is the entry section, P1 process is there and P1 process executes the statement number 1. The statement number 1 says that load the value of R0, load the value of lock in R0. So R0 register for P1 process contains a value, whatever value it is. Let us say the value of lock is 0. So R0 value is 0, after which the process is preempted and P2 process starts the execution. P2 process checks the statement 1, P2 process also in the register finds out the value of lock as 0 because no change has been made. So P2 will also observe the same thing. So let us say the register in which P2 is using is R1, not the R0. There will be a conflict if you take the same register. So statement number 2 is saying compare R0 with 0, okay. Compare R0 with 0, here you are saying that compare R1 with 0, okay. If we are comparing R1 with 0, yes, it is 0. So since this is 0, the statement number 3 does not mean anything. We will go to the statement number 4, wherein the value of lock will be set as 1 and then we can enter the critical section. So P2 process is entering the critical section. Now after this P1 resumes. When P1 resumes, P1 checks the statement number 2. It already has stored the value of lock in R0, which is 0. Just see this. Say statement number 2 says that compare the value of R0 with 0. Yes, it is 0. So statement number 3 does not mean anything. We are going to statement number 4. It will also set the value of lock as 1. Lock की value 1 ही थी और हमने 1 ही set कर दिया again. And then since the value of lock was 0, P1 process can enter the critical section. Have you seen that? The process P1 is entering the critical section, P2 is also entering the critical section. It means that two people are entering the critical section at the same time. Fine. So mutual exclusion is not achieved. This is the primary thing that you should achieve. The mutual exclusion with this kind of the solution is not achieved. Now, what is the reason that this condition is not satisfied? We will try to understand it later, but let us take another example. P1 executes the statement number 1. So P1 is executing this statement and is storing the value of R0 as 0, let us say, and then P2 executes statement number 1, 2 and 3. Okay. P2 executes the statement number 1, 2 and 3. So in P2, let us say the register is different. So R1 stores the value 0 and then it is compared with 0, which is satisfied, and jump if not 0, yes, it is 0. So no need to go back. So statement number 1, 2, 3 satisfied, and then we are preempting this. The process number P2 is preempted here. Then process number P1 checks the value of R0. Okay, process number P1 checks the statement number 2. It compares it with statement number 2. So since it is comparing with the statement number 0, it is again the 0 value, yes. So, statement number 3 does not mean, it means if you allow this thing to happen, then multiple process can enter the critical section. We have seen in the last example that if two processes are seeing the same value, obviously two processes can enter the critical section. If more than two processes are entering the more than two processes are seeing the same value, more than two processes can also enter the critical section. It means there can be n processes which can enter the critical section. You can see that there can be n processes which can enter the critical section. See, P1 process stores the value of lock, P2 process stores the value of lock, P3 process stores the value of lock, Pn process stores the value of lock in some variable, and then P1 executes statement number 2, 3, 4, 5. Since it is seeing the value 0, it will enter the critical section. P2 is also seeing the value 0, so it can also enter the critical section. Similarly, Pn process is also seeing the value of lock as 0, it will also enter the critical section. So, you can see that multiple processes are entering the critical section at the same time. So, this solution is not good. So, where is the problem? The problem is that you are allowing the lock value in the R0, and then you are comparing R0 with 0, and then after 3 statements you are actually doing this, setting the value of lock as 1. Why not exchange these two statements, or let us put this value or the fourth number statement at statement number 2. So, here is the solution. You have loaded the value of lock in R0, and then you are storing one value in the lock. Okay, you are storing one value in the lock. So, you have changed the sequence of this statement. First, you have said you have executed statement number 1, then 4 number is now the second number statement. So, it is something like there is a dressing room, and in the dressing room there is a tag. So, it is either vacant or occupied. If you have to enter the dressing room, so what you say that you go to the dressing room, you take the tag of the dressing room in your pocket, and then you apply another tag O, occupied, there. Okay, and then after some time you open the tag and just see that whether this tag is vacant or occupied. If it is vacant, enter the critical section. If it is not vacant, it is O, occupied, go to the critical section again, go to the dressing room again, and again do the same activity. वहाँ का टैग उठा के अपने पॉकेट में रख लीजिए और वहाँ पे नया टैग अपनी तरफ से ऑक्युपाइड लगा दीजिए, एंड अगेन सी इफ दिस इज वैकेंट. सो वैकेंट और ऑक्युपाइड, वैकेंट है तो एंट्री हो जाएगी, ऑक्युपाइड है तो एंट्री नहीं होगी. सिमिलर थिंग इज डन हियर. पहले लोड कर रहे हैं हम लॉक की वैल्यू, और लोड करने के बाद वहाँ पे ऑक्युपाइड सेट लगा रहे हैं, मतलब कि लॉक में 1 रख दे रहे हैं. ओके, नाउ लेट्स सी दिस सॉल्यूशन वंस अगेन. दिस सॉल्यूशन इज सीन and the statements are executed. P1 process executes statement number 1. P1 process says that R0 value is taken in some variable, lock की value को हमने R0 में ले लिया. So R0 now contains let's say 0. P2 process, इसका preemption हो गया P1 process का. P2 process is checking the statement 1. P2 process ने भी यही देखा, क्या देखा, रजिस्टर की वैल्यू 0. After this statement number 2, setting the value of lock as 1, यहाँ पे हमने lock की value को 1 कर दिया. Then comparing it with 0, yes it is 0. If it is 0, no need to go back, you can enter the critical section. So process number P2 enters the critical section. Okay, now the turn of P1. P1 is saying that 2 number statement, it sets the value of lock as 1, and in the statement number 3 it is comparing the value as 0. Yes it is 0, the value of R0 is 0, register value is 0. So it can enter the critical section because it is not 0. So critical section is allowed for process number P1 also. It means once again the 2 processes have entered the critical section simultaneously. It means that multiple processes can enter the critical section simultaneously if they are preempted after statement number 1. So where is the problem? Why this problem has again arisen even after changing the statement sequence? So it is happening because we are doing this statement, then we are doing this statement. It means that we are allowing first statement and then the second statement, and we are allowing the preemptions to take place in between. So let us not allow the preemption to take place in between. It means that these two statements should be unified in one. We are saying that this is test set lock. What is doing it? It is testing, then setting the value of the lock here. So, it is test set lock TSL. So, let this run at in one unit. So, we are saying that this is statement number 1, then 2, then 3, and so on and so forth. So, P1 process is executing statement number 1, okay, means these two statements. So, P1 process has set the value of lock as 1, and let us say the initial value of lock was 0. Then P2 process, when executes the statement number 1, it will see the value of lock as 1, not 0. So, P2 process will see the value of lock as 0, it executes statement number 2, which is saying that it will compare it with 0. Since it is 0, jump if not 0, it will again go to this, and it will, if it is going to this, the statement number 1 will be executed. It means this is checking again and again, and then P1 process executes statement number 2. The value that is it has seen the of lock was 0 obviously. Statement number 3 will be skipped because we are checking the value of R0 as 0, and it will, the process P1 will enter the critical section. So, we have allowed the critical section execution with the help of the lock variable. So, now let us see whether all those conditions that we have discussed in beginning are satisfied here or not. The first property, the mutual exclusion. Obviously, if one process is executing the critical section, other cannot. Okay, it means the mutual exclusion is allowed. Okay. Now, if one process has to enter the critical section, then it will check the TSL or it will execute the TSL, means the two statements which we have unified in one. So, only that process will check the TSL which is interested. So, progress property is satisfied. One process which does not have to enter the critical section will not restrict the other process to enter the critical section. So, there is no conflict here. Then bounded wait, no, bounded wait is not satisfied. We have not applied anything by which we can restrict a process to enter the critical section for multiple times. And architectural neutrality, अगर हमें दो स्टेटमेंट को एक साथ रन करना है तो इसका मतलब क्या हुआ कि मुझे कोई हार्डवेयर बनाना पड़ेगा जिसमें दो स्टेटमेंट रखना पड़ेगा. So, we will have to do some kind of the hardware mechanism. This is not a software solution then. So, this is a hardware solution. इसका मतलब क्या है कि हार्डवेयर तो डिवाइस डिपेंडेंट हो गई, डिवाइस डिपेंडेंट हो गया, इसका मतलब है कि आर्किटेक्चरल न्यूट्रल नहीं है. So, this solution with the TSL is not architectural neutral. Now, let us see one more thing. Let us say there is a process P1, it has a priority 3, so it enters the critical section. Now, there is a process number P2 coming, P2 has a priority 1, so obviously P2 has a higher priority since P1 process has entered the critical section, and in between execution of the critical section we have preempted P1 process. Obviously, we will preempt for the high priority process. So, P1 process has entered the critical section, and in the meantime we have taken the critical section back from here. Now, P2 process execution के लिए क्या करेंगे, P1 को preempt कर देंगे. Okay? P1 is waiting. Obviously बात है कि जब P1 को तब resume करेंगे जबकि हमारा P2 process finish हो गया. So, P1 process is there in the queue waiting. Then P1 process, हमने जो कोड बनाया होगा ऐसे बनाया होगा कि एंट्री सेक्शन लगाया होगा, क्रिटिकल सेक्शन, देन एग्जिट. सो P1 process has done with the entry section, it is doing the critical section, that means it will not have executed the exit section. If it has not executed the critical section, it means it will not finish. So, P2 cannot leave the hurdle, P1 can also not leave, it means they are in the spin lock. So, the solution would be that while entering the critical section, disable the interrupt, and while exiting the critical section, enable the interrupt. So, this is the reference for this lecture. Thank you.